Hello, everyone, and welcome to the 15th edition of Impulse Talks, coming to you from Paris. We're glad to have you with us today to talk about digital construction. I'm Gabriel, and I'm a consultant at Impulse. And our ambition with these Impulse Talks is to provide an international overview of how tech is developing in construction, cities, industries, and beyond. So every 2 months, we feature some of the best startups alongside with corporates, leaders, to cover topics such as Industry 4.0, Smart City, digital constructions, as it is the case today. As a reminder, please turn off your microphones and your cameras to make this session run as smooth as possible. And for information, this session is being recorded. So before introducing our speakers for today, just a few words about Impulse Partners. At Impulse, we're passionate about innovation, and our mission is to support an ecosystem of corporates, startups, and investors accelerate innovation across the value chain from construction, real estate, to topics such as smart city and energy. So even though the construction sector as a whole is one of the largest in the world, it remains largely under optimized, partly because it's really fragmented, ruled by local regulations, and really unable to address global environmental and productivity challenge. So we believe there's a huge opportunity for innovation and that startups can help reshape the industry and improve efficiency and sustainability. So to speed up innovation, we use a unique approach that we've iterated and refined for the last 8 years at Impulse. On one hand, we design and operate over 18 theme-specific labs through which we detect the most promising startups and connect them with corporates or investors. On the other hand, we provide our clients personalized advisory services to speed up their innovation agenda thanks to our 30+ experts. And finally, we help companies design, test, and launch innovative products through Impulse Studio. So just a quick snapshot of our labs. We design our labs around specific needs of the industry. So it can range from digital construction and robotics to circular economy and health and safety, for instance. So for each lab, we gather startups, corporates, and investors with the goal to generate inorganic partnerships. So essentially collaboration that wouldn't happen otherwise. And that's why we created our innovation labs to really bridge the gap between these actors and speed up pragmatic innovation. We work with an important international industry leader group that we've gathered over 1,000 startups that we help grow and accelerate their go-to-market strategy. So part of our job is really to bring together the whole value chain across geographies, hence why we're here today and why we created these Impulse Talks. In today's session, we're lucky to have over 60 participants coming across 20 countries. So we really thank you for being here and taking the time to gather around such an interesting team. In today's talk, we're happy to have with us very interesting companies that are transforming digital construction. We'll first hear from Kurt Zeidler from Gall Zeidler Consultants, and then we'll have 5-minute presentations of 4 entrepreneurs based in Germany, Norway, and the UK. We'll finally close this talk with a few minutes dedicated to Q&As. And to do so, do not hesitate to use the chat to ask any questions you might have for our guest today. So we're glad to introduce you today to Kurt Zeidler, principal and co-founder at Gall Zeidler Consultants, an international engineering consultancy specialized in solutions for tunnel and underground schemes. If you have any questions during the presentations, feel free to ask them in the chat and we will bring them up at the end if we have time. Thank you. So please, Kurt, you can start introducing yourself and the company.
Thank you very much for the invitation to have a quick presentation here on digital tools in construction. I just wanted to warn that my presentation is very much leaning towards tunnel construction rather than any other construction, but I'm aware that there is not only tunnels around, there is also other construction where digital tools are being used very successfully. When we think of digitalization of construction and the whole process around projects, we always think of building information modeling the first, and there is only other features and other digital tools come later. BIM modeling is nothing else than providing us an environment for hosting all information about a project and about a future structure. And ideally, that should be initiated from the very beginning, from the very onset in the early days of a project, and then continued to build up during the various different design stages up to the construction, and then also being used and implemented during the operation and maintenance. It basically creates a virtual asset for the total project life cycle. And that means it's not only design, but also procurement of parts for the construction, as well as spare parts. And then, of course, during the operation and maintenance, it provides important information for the implementation of a certain repair methods or a certain repair and for the spare part purchasing. We have different understanding these days in various different places about BIM. Some people see only 3D modeling, and others think it's computational design or just visualization, basically walking into a structure. But it goes more beyond that. It goes into clash detection up to the 4D and 5D modeling, which is being used at some projects around the world. What BIM offers us is an improvement in the project delivery, in particular in the delivery certainty, but also in the asset management and in the collaboration between various different trades during the construction and before that, various different disciplines. In the UK and in Europe, BIM is implemented more strictly following the ISO 19650, which is a guideline for the procedure for instance, storing all the information in a common data environment. The common data environment is not just a dump for information and files. It's important to structure that and to organize that and manage it such that information can be obtained in an efficient way and also in a reliable way. And it's basically a source of truth about the project. And if somebody looks up for information on this common data environment or data storage, he must be able to rely on the information and that this information is the latest information. So that's all part of the management, and that's also guided by the ISO. It also allows shows the procedure for a federated scheme, which is very important. Federated scheme means that all information is flowing together and is built with 3D scheme, for instance, into a 3D model. So it's not only the 3D model itself, it's part of it. It's all the assets shown within the 3D model. And the ISO doesn't specify any specific software. There is lots of softwares around which are helping to build up BIM models, and there will be future developments in these softwares. But it requires a workflow, and it requires a workflow from the very beginning, and it requires also our rethinking about these workflows on all sides, on the client side, owner side, as well as the engineer side during the design, as well as the engineer side during the construction. In North America, BIM is not very often used. Many owners are still not using BIM, but some owners implement BIM sometimes at a relatively late stage in the project, which is unfortunately not providing the most benefit of BIM, but still it is it uses parts of BIM, for instance, for clash detection or for information on environmental situations and so on. So there is a slightly different understanding in the, or different use of BIM in the States, but ISO is still a basis for all those approaches. BIM is probably front-loading the efforts during a design and whole project life. When you look at this little chart on the left bottom side here, you see the traditional way of design starts out with a relatively low effort, and then it increases up to just the time before construction. I mean, I frequently see that the real effort is then basically just before construction when we use the traditional approach, while BIM tries to avoid it. Has a higher effort at the beginning, causes a bigger effort in the beginning, but at the same time, when you look at this reddish curve here, any cost for changes increases dramatically with the duration of a project. So the worst is, of course, if you have to change something to a construction or even more during the operation maintenance period of a structure, because when you have to change something, then you have certainly a major knock-on effect on other elements of the structure around it, and that costs much more money. So the cost benefit of BIM is that these changes should be implemented, the errors should be implemented, should be found relatively early, and the changes implemented early in the life of a project, where changes are relatively simple by changing models, by changing digital information, rather than changing material out there or changing beams or something like that. Another example is the use for clash detection. As I mentioned before, this is just an example from a project in North America, where the client decided well into the project that he wants to use BIM for a for clash detection of his project, in his structure, and he wanted to bring all the architectural, structural, and other models together in a federated model, which is then showing everything, every element of the project, every element of the structure in that model, and then through regular coordination meetings, find out clashes, find out problems where probably one discipline is affecting another discipline in a negative way, or where a trade might come in later than required because it should come in earlier to do its work. So that's one understanding of BIM as well. We will have, of course, increasing computer power. We have all seen that in the past, rapidly developing computer power, and that will find its way into BIM modeling as well, and of course will improve BIM modeling. And software developers continuously develop new software to more efficiently and more powerfully use BIM models in future. But on the other hand, it needs standardization of BIM modeling, and I think that's probably a major task for the near future for engineers and clients to standardize those procedures to make the best use out of BIM. And as I mentioned at the beginning, there is more than BIM. There are other ways of other digital tools in the construction, such like, for instance, using real-time settlement monitoring and real-time monitoring of the performance of a TBM, which can then be used with the help or the support of artificial intelligence to predict certain behaviors, to predict the performance of a TBM or predict settlements based on real monitoring data. And that's important. It's not based on assumptions, it's based on real monitoring data. And that's certainly a very exciting part. It's only one part of the digital world, which will be influencing the future of our construction. So thank you very much. I hope everybody found something interesting in this. And I think that's it for my 10 minutes. Thank you.
Thanks a lot, Kurt, for your presentation. We will now move to the startup use case presentations with Caroline, co-founder and COO at Genie Vision.
Yes, good afternoon, everybody. I am glad to be here around the table this afternoon. I present myself, Caroline Zigrand, co-founder of Genie Vision. Before I start my presentation, I would like that you put yourself, if it's not the case yet, in the shoes of construction stakeholders investing into BIM and asking yourself, how can I optimize my BIM all through the life cycle of a project? How can I optimize the control phase? How can I optimize the cost and beside that the quality? How can I ensure that I have a right collaboration, follow-up and coordination within my projects? So keeping those questions into mind, let me present you Genie Vision. So Genie Vision is a SaaS software solution that allows to benchmark the 3D model against reality thanks to augmented reality. So a virtual layer, the 3D, that is interacting with the construction sites, not only via a visual object, but also via data behind those objects, and thanks to a mobile device. So the idea behind that is really to pocket the 3D, take it out from the design and conception phase, and build profit for the project stakeholders. So the project evolved keeping in mind, the productivity stakes on the construction field. So we understood clearly that there were market pressure to build better, faster, at lower cost, high impact of failure cost, and eroding, of course, margin, and also high investment in innovation and technologies, talking also, as Mr. Zeller said, about BIM innovation. So there is talking about failure cost. We understood that there were a big part of the construction budget that was allocated to the error management. And talking about BIM, we understood also that there were a very good maturity at conception and design phase, while at execution and operation and maintenance, it is very low. And indeed, it is at that level that if we look the overall budget of a project on its life cycle, it is the most important. So Genie Vision is really there to help to slash failure costs and optimize BIM investment. And this is done thanks to this smart viewer that is used for the entire life cycle of the building, from the conception to the operation, putting the solution in the hand of a modeler, site foreman, engineer, PMC, BIM, and operator. And we do it mainly based on 3 types of use cases. The first type of use cases is the possibility through our solution to monitor the execution. So make sure that what is executed is perfectly aligned with the model itself. So we are not talking about the 2D here, it's really the 3D. Make sure that the execution and the installation is done correctly. Be able to preview the upcoming work and make sure that there is no physical clashes, no clashes with the planning, make sure that we monitor all kind of deviation. For example, in the openings, are they at the right place, correctly sized, the number of openings are there. So it's really there to visualize the plan and optimize the execution. The second part of use cases on which we help is really the other way around, monitor the 3D model against the reality. So there it's really make sure that we build a correct as-built and enrich the model based on better coordination. Let's take a concrete example of refurbishment of a project. So we have created 3D model thanks to scan technologies and so on. And we want to make sure that we have the right model to then do the right bidding, the right assessment, the right coordination on site, and that we do not miss anything. The third type of use cases are collaboration and follow-up. It's true that via GeniVision on site, we collect a bunch of information, visual one, pictures with the 3D against the reality, the place where those pictures has been taken, timestamp, who has created, and it can be really used to share the information among teams, but also connect those information directly to the 3D model. So GeniVision, the process is quite simple. You have a 3D model that you pose on a portal that you process and make it available through an application for the operator on site, which record the model, calibrate it, and do the reporting job by comparing both reality 3D and on-site reality. Afterwards, everything that has been collected is available through the application and through the portal. Behind that concept, there are process bringing 3D into augmented reality thanks to a unique high-tech process, avoiding any problem of sizes and using different type of format. The main one is Revit and IFC. And also making sure that GeniVision is focused on its core product, which is the smart viewer, and making sure that we are integrated into the existing ecosystem of our customer by providing an open solution that can be easily integrated to what already has been implemented to the customer side. So if we take back the question raised at the beginning, we understand that this kind of solution via the smart viewer can allow the fact that we carry the 3D on site, that we can benchmark this 3D against the reality, make sure that this 3D is confirmed to what the work is done, confirm to what is the execution, and deliver at the end a digital twin that can benefit the project all through its life cycle. So it is done thanks to augmented reality, but we have in mind that we can go further with other embedded technology coming soon. So do not hesitate to ask questions at the end if you have any, or to contact us. Thank you.
Thanks a lot, Caroline, for your presentation. I think we've had a question in the comments from Morgane Josic. 1,308 billions, 13,08 milliards. Je crois qu'elle faisait référence. Oui, c'est milliards. Billions is a milliard. Does that answer your question?
Sorry, thank you very much for. Yes, I was quite impressed by this figure. I think it's probably million instead of milliard. So I don't know. It was on at the beginning of the slideshow.
Yeah, it's a European statement. I can forward you the literature on which we base those figures. No problem.
Okay.
Thank you for your question. We have another question from Mathilde. What's your competitive advantage?
Yeah, our competitive advantage is really the fact that the fact that we can support or customer all through the life cycle of the project with a technology that's quite simple and easy to use compared to other kind of technology which could quickly be very costly. And we are there to really build smart savings thanks to that. Does it answer the question?
Mathilde is also asking, who is your customer then?
Yeah, so our customers are mainly construction actors. So we are, as I said in the previous slide, so maybe I can come back to it. Do you still see my screen, or? I will share it again.
Yes. No, we can't see your screen. Currently it's like pocket.
Do you remember what do you remember what the slide is? The slide number?
Yeah, so here. Okay, so our customer, for the moment, we are really focusing on talking to site foreman and engineer. So allowing those two persons for the site foreman to do, as I said, the first type of use case, be able to control what has been executed on site, do snagging, really report any kind of non-conformities, and afterwards push it into a work progress flow. And the second type of users that we have focused on is the engineer working on the BIM and who are looking for in their mission to support either the customer, either the general contractor, to have an up-to-date as-built. So that's the two main focus for the moment. Of course, we can even go further and help the user in operation and maintenance phase, helping them to get access to the data we collect all through the previous phases, and also be able, thanks to the 3D model, to locate where are the different installations, be able also to access visually what is behind the wall, what is behind the ceiling, and access to the data which are linked to those different objects.
Thank you, Caroline, for your answer. So we're going to move forward now. Coming up, we have Philippe Akes, Chief Business Officer at VREX, with us today. Hello, Philippe.
Hi, good morning, good afternoon to everyone. I see we have a lot of people here waiting. So I'm going to share my screen now, and we're going to look at VREX. Here we go. Yeah. There you go. Can see my screen?
Yeah.
Okay, cool. All right, so I was told I had 5 minutes to present VREX. I usually take 1 hour. So I'm going to make it real short and sweet. So what VREX is about is virtual reality for project in BIM. And basically, we work on collaboration in VR, but not only. We have a few customers already working with us. Some you know already, of course, like Bouygues, Artelia, NCC, Schlumberger, Bosch, etc. Those guys are using VR and VREX on a regular basis now. Some of them are on a daily basis and on many projects. So basically, those people have actually integrated VR in their process of the BIM process, where they actually design and collaborate with many people to make the project as good as possible before they even start building anything. In VR, you have 2 different families that people think about VR. Usually they think about what's on the right-hand side. This is coming a picture from Enscape, which is another solution. So Enscape is a VR solution that allows you to make really great pictures. This is what people use to sell and make people dream about their product or their project. So it's really good for communication. It's really good for marketing. just a little bit of work needed to get this kind of picture. So from a basic model, which is like on the left-hand side, you can end up with a beautiful model on the right-hand side. It just requires quite some work when it comes to designing this. And this cannot be used on a weekly basis to a project where everything is moving all the time. So this is not what VREX does. What VREX does is on the left-hand side. What we do is we work with more technical things. We address our work to engineers and yeah, a bunch of people involved in the process, but it's not about looking good, it's about making it right, which is slightly different kind of use case. A lot of our customers actually have the VR headset, the PCs, everything, and they actually use Enscape for one phase of the project, like in the beginning or at the end, or to sell the idea. And they use VREX along the life cycle of the project. So it's really like two different use cases, same equipment, but it's a different kind of a use of VR. So when you are in VREX, you have an avatar you can see in the middle. Everybody has an avatar. You can join, of course, with a VR headset. You can join from a standard laptop as well. If you have a laptop, you will be also with an avatar that looks like a little PC. And you will be able to fly around and point at things and measure, take pictures, access to data. You can do everything as much as the other ones. You're part of the meeting. And so in VREX, you are all together in the same room. We call it VR room. And you're all together in there and you collaborate. You click an object, you got the data, you open a BCF, and then you can fly and just teleport yourself to that particular place in the model. You can teleport everyone. You can teleport yourself to someone else. You can teleport this guy to you. And you can just collaborate and everybody's sharing the same view. You can just discuss about the specific case. And in VREX, you make a decision. You decide, yes, we do this, no, we do that. You get information, you connect with some other guys, and then you get things done. Basically, a decision-making tool in VR. So if you haven't tried VR before, it's difficult for people to understand the effect of being in a virtual reality on a scale of 1-to-1, because you really are in the building. So it's really important to try if you haven't tried yet. VR, I really encourage you to, if you have an opportunity, put the headset on, go into a model, and you will see this is another world, really. We talk about digital meetings, okay, and VR can be used with many use cases. I just made a couple here, but there's many use cases. One of them is really nice is when you need to talk or get the feedback from people who are going to use the building. For instance, the nurse on the bottom there, she's going to work in a hospital and she's going to have some specific requirements about how she's going to handle her job every day. If she's not a beamer, she doesn't know 3D modeling. And it will be difficult for her to understand a 3D model to look at on the screen. But if you put a headset on her, then suddenly she can definitely see, oh, this is how it's going to look like. This is how I'm going to be able to operate. She can give you feedback, ask questions, and validate some points or just create an issue that says, hey, here we have an issue. This cannot work for me because of this and that. And you don't know because you are a really good engineer, but you're not a nurse, right? And the same goes for people in many different kind of buildings, students, teachers, operators in a factory. Many people actually can have their own feedback that will help making the model even better than the one has been designed by the first engineers. So this is one of the use cases. Non-beamers use VR to give you feedback, input, and validation. Okay, and of course, you will do a lot of collaboration between all the trades. Electrician and plumbers, architects and structural engineers, everybody can join in the same room and see the models with a different perspective and give their advice and make a decision again. You can access VREX from anywhere. It's a cloud-based, so you don't need to know BIM at all. You can just put the headset on, fly around, ask questions, and make sure that you understand what's going to happen. And you don't need to have VR because you can do it from your own laptop. So this is pretty much how it works, okay? You got a guy with an avatar, he's got a laser, you point at things to say, yeah, maybe we should do this, we should do that, measuring and moving things. The interesting part with VREX is that we are integrated in the BIM process. This is not something you do on the side of your BIM process. It's integrated with many other platforms already. Those you may know already, called BIMtrack, BIM Collab, BIMsync, StreamBIM, and of course Navisworks and BIM 360 from Autodesk. Plus we do have now Oracle Iconex as well connected, and we're working on way more. So basically, whatever tool you use today for your BIM process, we can actually connect to it. You can import models, BIM models, CAD models into VREX, and you can import and export from VREX issues. So you can open an issue that you created in BIMtrack, for instance, in VREX. You can make a decision, a comment, or whatever. And if you find something different or find another issue that was not detected before, and when you are in VREX, you can create an issue, a BCF, and this will be automatically also registered in your BIM platform. So this is totally integrated in your BIM process, okay? This is not something on the side. Yeah, I can talk about it forever, but this is the main principle. Another thing is we have the capacity to use point clouds, and like we saw before, but that's in VR. And point cloud is used in two main cases. One is for industry. Very often we see that in industry, there's a lot of machine replacement and change of production lines. So people, what they do usually now is they make a scan of the actual production line, and they will make models of the new equipment or about the new building or extension they want to make, and they will compare both in VR, and then they can see if everything is correct. Another use case, of course, is as built. So you can just check with the point cloud if it was correctly done compared to the model that was designed before. Okay. So either rehab or just retrofit like this in the industrial world. Now see, they scanned the production line, or at least this part of the production, created this new equipment and just made sure that it was fitting with the rest of the existing equipment. Okay, so that's one of the use cases we have. Another use case, and one out of many, but I took this one. It's called Universal Design. That's a case in Norway with Statsbygg. This building was supposed to be really good, and someone found out that there might be some issues when it comes to access for people on a wheelchair. It happens to be that Tim in Skanska is also a BIM manager and is also a wheelchair. So they decided to ask him to check the full model. And it was a big meeting. There was a lot of people involved, even the officials. And Tim was just leading the whole session. And he was, of course, in VR. And this is what he found. After 2 hours of 2 sessions of 1 hour, he found about something around 50 issues for access for wheelchairs in the building. Any places, locker room, toilets, exit of elevators, and just to name a few. So there was a lot of mistakes done, and because this is a public building, it had to be totally accessible for people in a wheelchair. So at the end of the day, they had to reshuffle and redo a lot of the design of this building, and you know, they saved a lot of money because they would have had to do it anyway. If they build it this way, they would have to change a lot of things. So they saved a huge amount of money just using this 2-hour session with Kim. And I think this is it for me. I hope, yes, I stayed in my 5 minutes. So I think if you have any questions, just one thing, you know, there is this BIM World show coming in Paris in a couple of weeks. So if you know any of you guys going to BIM World in Paris, please drop by our booth. We have a nice booth, and you can try for yourself and see how good this VR solution can be for your project. And that's it for me. You're on mute, Gabriel.
Oh, can you hear me?
Yeah.
Okay, good. Thanks for your presentation. We have a question from Benedict from Saint-Gobain, Germany, asking what's the advantage of coordinating in VR, and is coordination also works on screen?
On screen. What do you mean on screen? Sorry.
Maybe answer the first question.
Yeah.
Maybe.
Well, what's the advantage of coordination in VR? Okay. What people do usually, they make their models in Revit or Archicad, one of those. Then they put them all into Navisworks. They make a federated model and they make the clashes, right? And when they have the clashes in a project, you may have hundreds of different clashes that could be easily sorted and fixed. And then there's some clashes which are harder to understand. And maybe it's not so easy for people from different trades to see why this is an issue for me and why is it an issue for you. And then when you are in VR, you see the models not only through a small window like a screen, you are in the model. And again, as I said, as long as you haven't tried VR, it's difficult to explain to you how this is. I would say an analogy, okay? When you are, if you do scuba diving, if you are just snorkeling, okay, you see the fish, but you're not with the fish. That's screen. But if you're diving, then you are with the fish, and it's a totally different experience. Okay, it's pretty similar to being on the screen and being in VR, snorkeling and diving. So when you do it on the screen, you're just snorkeling. You don't touch the fish. When you're diving, you're with the fish. You live with them. You see it different, and you feel it in your body, and you feel the whole environment, and you see different things. You see perspective. You see dimensions, you see a lot of different things. I can tell you, everybody who tries, just say, okay, now I get it, but you need to try. That's all.
That's a great analogy. I think that answers the question. If anybody has any other question, please let us know in the comment. We can always go back at the end of the presentation. Coming up next, we have Sebastian, CEO from HAL Robotics. Hello, Sebastian.
Hello. Hopefully, hello. Cool. Yeah. Hi there. Cool. Yes. So my name is Sebastian Andras. I am CEO of HAL Robotics. We deliver tailored software solutions for flexible robot programming in manufacturing, construction, and creative industries. We specialize in the programming of variable, complex, and particularly unique tasks, be that 3D printing construction elements, all the way to throwing and catching cocktails. Our unique approach allows mass customization of components, be they in metal, timber, or concrete. On the left here, we have a sheet metal deformation project by CETA, which is part of the Royal Danish Academy, in which a robot presses repeatedly on a sheet of metal to change its shape and add some structural integrity. In the middle is a doubly curved timber structure in which every single beam is uniquely machined to keep those flat panels perfectly flat and planar. And on the far right-hand side, we have a 3D printed column by Xtree, who some of you may know, for a school in Aix-en-Provence in the south of France. Our solution also enhances R&D through access to sensors, novel human-machine interfaces, and CAD-based toolpath programming. Here again, on the left, we have a glass artist who's collaborating with a robot to create these kind of bent glass rods. Everything is programmed through CAD, but it's that man-machine interface that allows the process to work properly. In the middle is a steam bending wood project where we're using motion capture cameras, the sort of thing you see in filmmaking, to adapt the robot toolpaths in real time to compensate for the heterogeneity of the timber. Timber doesn't like to bend exactly as we model, so we're constantly comparing the real shape with the CAD shape and adapting what the robots are doing to match that. And lastly, on the far right is 3D printing of recycled plastics with crushed stone additives to create this really hard-wearing street furniture. Yeah, it looks very cool as well. And then a few additional projects worth highlighting here. On the left again, we have some real-time data logging of a welding application. So that's all running from a low-cost edge device, which in this case is actually a Raspberry Pi, checking for any anomalies and then also being able to trace back any defects and work out why they occurred once you know that they've occurred. In the middle, we have an embedded trajectory planning software for a modular robot arm by a company called Innova Robotics. Also, really cool project. And what they're doing is really interesting and impressive. And then on the far right-hand side, we've also worked on the deployment of robots in unstructured environments. So this is a construction site, navigating the site and drilling holes and inserting anchors for drop ceilings and service runs. We offer our clients a full range of services to cover their needs regardless of where they are on their automation journey, from exploring where automation could fit into their current workflows, through to equipment selection, automated reprogramming tools, collaborative developments, and of course training once everything is actually set up and running. Our services are all based on a proprietary software we call the HAL Robotics Framework, which covers full robot programming workflows. So cell modeling, toolpath creation, motion planning, simulation, code generation, as well as inter-device communication for code uploading and adaptive programming. So getting that feedback back into the loop and changing what the robot's doing in real time. And we've designed that framework from the ground up to run anywhere from low-powered edge devices, as we saw with the welding example, all the way through to being embedded into CAD software and even pushed up to the cloud into containers and distributed into scalable applications. Over the past 7 years, we've had this technology out and about, and it's been used to deliver solutions for multinationals and SMEs in aerospace, construction, locomotive, food and beverage, and many other industries, as well as supporting fundamental research at some of the world's top universities and research organizations. I was told I had to keep it brief, so that's the very brief version. Thank you very much for listening. Obviously, if there are any questions, please feel free to reach out now, later, or by email. Thanks.
I don't think we have any questions in the comment for now, but if anybody thinks about any questions, you can let us know. We can always go back at the end of all the presentations. So thanks a lot, Sebastian, for the presentation. I appreciate it. So for the last but not least startup, please welcome John Moreland-Lynn, Director of Corporate Development at Hypertunnel. Hello, John.
Hi.
The floor is yours.
Okay, thanks. So I've just shared my screen, I think. There we go. So Hypertunnel is a deep tech solution for underground space. So not just tunnels, but anything underground. And we can build or repair using deep tech. And the solution will prove to be cheaper, faster, safer, and more environmentally friendly than the currently available ways of building tunnels, etc. This is how we currently build tunnels. These are tunnel boring machines. This is state of the art. The technology is 150 years old, but has been improved over time. And they're fascinating machines. They're about 200 meters long. You see two of them here. And this is going into the Chiltern Hills, just north of London, a stretch for the high-speed 2 railway from London to Birmingham. And these are operated by Bouygues from France. And they're 8 meters in diameter and about 200 meters long. This is the biggest piece of equipment that we will use in our more modular approach to building tunnels. And we start from the beginning in the preparation phase, where traditionally you would do some core samples vertically at intervals of up to half a kilometer, which shows that a lot of geology is not seen on the tunnel path. Whereas we take a horizontal directional drill with core sample and go through the entire tunnel path, making sure that we can see everything. And then we use equipment that we've developed in-house, such as seismic and ground penetrating radar, to create a digital twin, like Kurt was saying earlier, in a BIM model. Kurt's been working with us, by the way, for the last 3 years, and we will be able to identify everything along that tunnel path and use virtual reality goggles so that you can walk through the virtual tunnel before it's even built. So here's our horizontal directional drilling equipment, putting some exploratory bores in to get the geological analysis. And then we use the same equipment to create the tunnel shape. And instead of a TBM that is only round, we can make it round, we can make it D-shaped, we can make it square, rectangular, whatever the client requires. So it's very flexible, and it can be any size you want, any length you want. This is the fun bit. So once we've installed the holes and we put a plastic pipe in, we then use swarm technology. So swarm technology has been around in nature for millennia. Ants building ant hills, for example. These are some examples in industry. This particular photo is of a grocery packing plant in the UK from Ocado, and our head of engineering, or their head of engineering, has just joined us to be our robotics engineer. And robots have been used in tunnels for years as well, but usually these tools inspect pipes or tunnels. They don't actually do anything. The difference with our robots is that they actually use the pipes to go outside the pipes into the geology. And you'll notice they're half pipe shaped. That's so that they can pass each other inside the pipes. Here's some bots passing each other inside the pipes as a swarm. And we might have hundreds or even 1,000 of these in our pipes, but they cost about 500 euros each. So 1,000 bots at 500 euros each is €500,000. And that TBM I showed you earlier, they cost between 10 and 50 million euros each. And they can only go down the tunnel, build the tunnel one step at a time. They go 10 to 20 meters per day. And Elon Musk has said, you know, they're 14 times slower than a garden snail, whereas our bots can build the tunnel simultaneously from all directions. And what we do with the bots is we first analyze the geology, then we use this drill bit that goes outside of the pipe into the geology and creates the outer shell like this using construction chemistry. It's been around for ages. These are some of the plumes that we've built. So we inject plumes and put them together and built as building blocks. They're very, very strong. They're as strong as structural concrete. And we don't just do them in a random fashion. We use artificial intelligence and create this digital twin of what we are going to do and what the robots are going to build. This is just showing that there's different sequences as well. What the AI tells the bots where to put the plumes. And once we've built the shell, as you see here, we can then disrupt the geology and make it very easy to excavate with a machine like this. This is autonomous. It drags through and takes out the excavated material on a conveyor belt. And you'll notice nobody has been in the tunnel yet. No humans have been in the tunnel, just autonomous vehicles. The final phase is to finish the tunnel with whatever completion the client requires. And we can leave behind the surveying equipment for the life of the asset. And don't just take our word. We've put together this very prestigious technical board. You can see Kurt there on it. We've got the director of global tunneling for Bouygues, the managing director of Vinci in the UK, and many other experts in the field of tunneling who have helped us develop this. And we don't just build tunnels, but we can also enlarge and repair and monitor, as I said. And we are looking at transport, utilities, underground assets, and mining. And I think that's my 5 minutes. So are there any questions? Any questions?
I don't think we have any questions in the chat for now. Thank you so much for presentation. So
Great.
Thanks to everyone for their time and for presenting their business. I think it was very insightful, and it gave everyone a good idea of what can be done in terms of innovation in the digital construction space. So it was very interesting. So if any of you have any questions for the presenters, now is the time. You can activate your microphone or just use the chat. Otherwise, I put my contact in the chat. So if anybody wants to be put in contact with any of the companies presented today, do not hesitate to reach out. So special thanks to our guests from Gall Zeidler Consultants, Genie Vision, VREX, Hall Robotics, and Hypertunnels. We appreciate your time with us today. And for your information, our next Impulse talk will take place on May 25th, and will be on the theme of Industry 4.0, sorry, followed by Smart City on July 6th, and Digital Construction back in September. If you'd like to give us any comments or feedbacks regarding today's session, please use this QR code. Do not hesitate to tell us about how you feel, what are your questions or comments. And also, if you'd like to be put in contact with any of the speakers today, you can also use this link to do so. I'll give you just a quick moment to put out your phone and scan the QR code if you would like to. Otherwise, I think we're gonna wrap up for today. Thanks again to everyone for their time. And we'll see you next time. Have a great day.
Okay, thank you. Bye-bye.
Thank you.
Merci, Gabriel.
Merci à tous.
Thank you, everyone. Thank you for your time.